Okay, then I will start. Thank you very much for the invitation to give this talk about AI for experiments here at the IAIS Open Lab. It is an honor for me to be here. And my name is Martin Welss. I work for Fraunhofer, IAIS in Germany. And I am the lead architect of AI for experiments, which is one of the results of the AI4EU project, which is funded by the European Union. So what is AI for experiments? What you see at first, it is a catalog of reusable AI tools. Currently we have nearly 200 building blocks or bricks in the catalog. We recently onboarded a lot of OpenML data sets as data brokers so that you can easily use them in your pipelines. And the main idea is to have those reusable building blocks to be composed into AI pipelines that can be deployed. Okay, so one of the ideas is also to have visual pipeline composition. So if you look at the above picture, then you see an audio pipeline, which is broken down into the building blocks. So we have the audio file broker, which feeds the audio streams into the pipeline. We have audio segmentation, then the stream is split up into speech-to-text processing, then adding punctuation, and in the parallel lane, there is speaker recognition, and then the audio dialogue creator fits everything together in the right order, and you have a nice textual representation of the dialogue. And the visual editor looks at the interface definitions of the components, and you can only make a connection if the interfaces match, if the data structures match together. And it is very easy then to add new building blocks to the pipeline. For example, in the lower picture, we have added a new node, topic extraction, that easily fits into the pipeline. And then in the result, you will get additionally to the dialogue representation also a list of the topics that are part of this, of the audio stream. So this all builds on the AI4EU container specification. To be as common and as easy to integrate as possible, we focused on using Docker containers. Plus, yes, please. Sorry, I can hear this.
I think Oleg has to mute himself.
Okay.
Oleg,
I will just continue. So it's a Docker container with additional properties. So we need the protobuf specification of the public interface. As you see on the right, there is a code snippet, which is a protobuf definition for the standard IRIS classification example. And as you can see, protobuf is quite simple, and it's meant to be simple. So it's simple by design. And we are using gRPC communication underneath. So this is a very, very important element of integration and interoperability. These two or three elements, gRPC communication, protobuf, and Docker container. So we really support, we are programming language agnostic, and it's easy to transport a model and to let it run in common environments. There is also the option to add a web UI for human interaction to a node, to a building block. It must be provided by the creator of the tool, but we have foreseen and reserved a port for it. It is all based on free and open source technologies. And there are also some recommendations for scalability and for training and GPU support. And recently we added support also for GRP streaming, which adds a whole new area of topologies and use cases that can be supported. And what is also important that it is not a lock-in. So if you create a container that fits into AI for experiments, it is just the standard Docker container with some additional properties. So you can run the same Docker container in many different environments that are completely independent from AI for experiments. You can run it in your Kubernetes cluster or wherever you want. So it's not a lock-in. You can, if you want to bring your tool into AI for experiments, you just have to add the gRPC and protobuf part additionally to what is already in the Docker container. What about intellectual property? So we must distinguish here between the AI for experiments platform, which will be the source code will be Eclipse Graphene, open source project. And on the other hand, we have the tools, the content that are presented in the catalog in a running instance of AI for experiments. And there we support open source tools, but also commercial tools. Both is possible, but each published tool must have a license. So it can be open source or commercial, and we support basically any type of license. It must be described, or there can be a link to the legal text if it's very long and complicated. So that's possible. And on AI for experiments, we store only metadata. So the Docker container is not stored inside AI for experiments. It is only referenced. We save a reference to the Docker image. So the Docker image tag. It's basically, we save descriptions and documentation. Of course, the interface definition, this is necessary. The protobuf file, this is important, imported into AI for experiments, and we save no binaries. So same for data sets, they are not imported. They are only accessed via data brokers. So here is the architecture of AI for experiments. So we see on the left-hand side the platform elements. We have the portal, we have Echo Compose, the visual editor, we have the onboarding, common data service. And interesting enough, it's also, so AI for experiments itself is running in a Kubernetes cluster. But this can be seen like an app store for AI components. So you need a place where to run and install them. So there's then the two green arrows make the transition between the central instance and the deployment into an execution environment. And currently, we support different Kubernetes flavors, Minikube on your laptop, Kubernetes plus GPU, but it can be many more. So those deployment clients are meant to be easy to write and easy to support, and there can be many. So it can be imagined to support deployment to Kubeflow or to Docker Compose, or maybe a cloud providers like Google Cloud Engine or Amazon. That's all possible. Currently, we support Kubernetes. And the cloud environment, of course, the Kubernetes environment can be a private cloud. So access to confidential data is possible. You bring the execution to the data into your company IT environment, so you have access to all your data and can use your credentials. And it is easy to integrate the deployment with other MLOps workflows. So this will be an interesting point to discuss, how we can support different workflows. Since we are relying on Docker containers and Kubernetes, of course, we can benefit from all the features that Kubernetes offers for scalability. So it can be a small environment, it can be a very big environment. And it is also possible to do model training, even with the same container, if it is prepared for it. So what are the real benefits of using gRPC as the communication layer? It is, first of all, it is programming language independent. So there are generators that create the stubs and skeletons based on the protobuf definition for many popular programming languages. And since it's Docker, you can install all the tools you like and you choose inside the container. It is simple and standardized. So Kubernetes itself is using gRPC for internal communication. NVIDIA is using gRPC for many communication paths inside their libraries, CUDA, for example. It is fast and efficient. And what is very, very important, the communication stubs can be created dynamically at runtime. So by using this, we can orchestrate the execution of pipelines according to the topology of generic pipelines that the orchestrator has never seen before. And this is not possible with RESTful communication. So this is an essential part using gRPC. We can generate all the communication automatically. So what is also part of the whole platform, it is our advanced orchestrator. It dispatches the messages according to the pipeline topology. So if you look at the picture on the right, it will start at the graphical user interface, and then the message will flow down to the app solver, and then they will flow up. So, and the orchestrator gets the topology and knows how the message will flow and will create all the artifacts, the stubs and skeletons on the fly. So there's no need for manually bringing and plugging all the nodes together. This is done using the visual editor and our orchestrator. We have streaming support. We support certain cyclic topologies. We have parallel execution of messages. So it's the orchestrator is multi-threaded. And it's, of course, tool and language, programming language agnostic. And to my knowledge, there's no other AI platform that offers a similar feature. So I think this is really a unique selling point. For training pipelines, the idea is that there should be a training method added, a training method added to the model. So in this example, we have the news classifier, and the news classifier has, of course, the classify method, which will be used in application. And if we add then the train model method also, which has a configuration which is shown here in the middle, then it is possible for a specific news trainer to control the training phase of the model. And it's also possible to connect, for example, a tensor board for diagnostic output if you, for example, have a model implemented in TensorFlow or in PyTorch. We have also utility nodes for a pipeline. Very important is the shared folder concept. So if you want to process binary data like video streams or audio streams, you need a way to share those binaries among the nodes. And there we have our shared folder, which provides a shared storage to all the nodes that are connected to the shared folder. So in this case, we have the folder data video incoming, which will be accessible by using this path by all the nodes in the pipeline. So they can all look into this directory. We have concepts for model initialization, will come probably early next year, and diagnostic tools. Currently, we have a tensor board. Then one of our ideas is to have a Jupyter Connect setup where you can easily work interactively with a model in a Jupyter notebook. And you can deploy it with one click. And thanks to protobuf and gRPC, this can all be automatically generated. And then if you have the notebook, if you open the notebook, then the connection to the model is already established, and you can interactively call some of the methods and import any tools that you would like to use inside this notebook. So it is easy to explore model properties with standard Python tools like Matplotlib, Pandas, or NumPy. And it's not yet available, but it will also come probably next year. So let me list some interesting use cases that we can imagine for research and development. So it's easy to quickly configure and deploy training pipelines. It is possible to create hybrid AI pipelines that combine symbolic and sub-symbolic tools. So I believe that the next big step in AI will be through combining several technologies from AI: planning, search, deep learning, and so on. And we need to make them interoperable. And for this, we need common interfaces. I will come to that later. So hybrid AI, I think, is very, very interesting to go beyond state of the art. We can imagine to have reproducibility of pipeline runs so that everything, what goes in and out, what data set has been used, what parameters, it can be saved and connected to a pipeline run. This is also a planned feature. There can be reusable building blocks for explainable or verifiable AI to make it easier to verify a pipeline after applying some changes. And of course, also very interesting is to use AutoML to reconfigure the topology and the hyperparameters of a pipeline for each iteration. So the interesting question is here: how do we do AutoML for a set of models, not only one model, but a set of models? So this is a very interesting question. So for education, there are also interesting use cases. You can use the pipelines to explain AI concepts. It is possible to exchange solutions, and they are easy to test because they have a standard interface. It is possible to have or to provide hands-on exercises and to let students implement parts of a pipeline, for example. You can have live classes and exercises with Jupyter Connect to interactively see what a model can do and to find out what is possible. And you can collaborate on solutions. So AI for Experiments also has a way to share models and to chat about models, to rate models. So this is also built into it. And you can work in teams to create a solution. And those collaboration does not need to be public. So you can also work on private solutions. You can decide if you want to publish it to the catalog or if you just want to share it with a collaborator. So what can we do as the next steps? What will be the advanced features that we can implement? And as I said, it can be hybrid AI components, so that we define standard interfaces or common interfaces to combine, for example, reasoning or knowledge-based systems with deep learning NLP models. So it's this will be very interesting to see, because we know that machine learning and deep learning models are sometimes easy to confuse. We can also add reasoning and SAT solvers and deep learning solutions to bring them together and go to the next level. We can have AutoML for a whole pipeline and define ways for hybrid learning, which is also very interesting. And then the next step would be to define cognitive architectures. So add planning and reasoning to deep learning and language-based models will be very, very interesting. And I think we are on a good way. We have the possibilities with Eclipse Graphene and AI for Experiments now at hand. But there are also industry use cases. The visual editor lets non-AI experts create and modify solutions. So you can give that to domain experts. For example, the audio pipeline I showed at the beginning. So if there's an expert on audio processing, it is possible to modify and create and deploy pipelines in a very fast way without having asked an expert to build a new pipeline. So it can be integrated with MLOps. There can be new types of deployments can be added easily, or specific deployments that add certain environment-specific properties. It is also possible to apply federation that's already built in AI for Experiments. You can run an internal private instance of AI for Experiments that synchronizes with a public instance. And then you can see, and you have the up-to-date public models, but can add your private models that are company internal. And of course, it can be used not only for application in production, but also for company internal research and model building. There are also business and sales use cases. So you can use the catalog to present your commercial AI tools to customers, use a playground for demos. So in the next year, there will be a small playground where you can execute some simple pipelines and public pipelines. It will be a public playground, so no confidential data there. You can use it to get in contact with potential customers and work in mixed teams, experts, AI experts and domain experts on proof of concepts. So I have tried to make the point already earlier. The idea of having common AI interfaces is very important. I think that integration and interoperability among different areas of AI is very, very important and enables us to make the next step. So here's one example for an audio interface that is part of a taxonomy. So it could be the area of audio processing, the task audio segmentation, and the type could be a deep neural network. And then the interface would look like this, and it should just be a suggestion. So the idea is to collect interfaces and find the least common denominator, to have those common interfaces that can be reused by other elements of the same area. And then we have a competition of tools. You can select the best tools that for the task at hand. And it's easier to compare the tools. So we have already talked about it. The source code of AI for experiments will become a Eclipse Graphene open source project. So it was really an interesting coincidence that just as we were thinking in AI4EU about how to ensure sustainability and ensuring that it will stay open source, the Eclipse Foundation moved to Europe and was also setting up this working group in AI. They were interested in AI projects. So it was really a very good cooperation, I think. And at the same time, the momentum of the original Acomos project of the Linux Foundation lost some of its speed and resources due to the Corona pandemic. And so the latest news is the Acomos project will be archived at the end of the year, and it will basically be continued as a branch called Eclipse Graphene, and we are happy that we can use it then in follow-up project. So it will be used in the IAIS Open Lab, as Boris and Gael have presented. It will be used in the AI for Europe effort. It will be used in the project Humane AI in the virtual lab, in AI for Media, and we have also here in Germany a regional initiative which is called KI NRW. So we plan to use and to improve the system beyond the end of the AI4EU project. So what would really be a good plan to see Eclipse Graphene as the beginning of an evolution? So we would like to invite you to work together with us on making this project a really good platform for AI development. So contribute and adopt it to your needs. So it's the Eclipse, it's Apache license, so you could even do private branches if you have commercial ideas. This is also possible, but the core will always remain open source. So that's what we meant by bringing it as an Eclipse open source project. And we can exchange ideas and concepts as runnable, reusable AI artifacts. So I think we are really at the beginning of the first of this journey or evolution for AI interoperability. So the last slide contains some useful links. So there is the central instance run by AI4EU experiments. We have a lot of tutorials on GitHub that are freely available. There is also, of course, the AI4EU homepage with more explanations and more tools. There is also a catalog, news and events. And most important, of course, the container specification that enables to onboard your tools on AI for experiments or Eclipse Graphene instances. Okay, thank you very much. How am I in time? Okay, I think.
Yeah. Thanks, Martin, and yeah, welcome on board. That's really cool. So we have a few other research-related presentations.